Lesson 91 is about solving a system of linear inequalities, and linear inequalities look like this. Instead of equations here, we have inequalities here. And the answer to a system of inequalities is not an ordered pair, it's a graph. It's a graph that's going to be shaded in an area where the truth is. There'll be a set of ordered pairs that represent answers that make both of these inequalities true at the same time. And we want to shade that region to represent that. Okay. The process goes as follows. Change each to an equation, convert to slope-intercept form. So we can graph both lines. The lines are going to be either dashed lines or solid lines, depending on the inequality only or the inequality with an equals to attached to it. Relate that to graphing on a number line, hollow circle and filled in circle. Okay, so a dashed line means that the line is boundary but not included. A solid line means that that's boundary and it is included. So if it has an equals to, you put the solid line. That's the most common mistake people make. They put solid lines on everything. I don't care about these dashed lines, I'm going to make everything a solid line. Okay? Open circles, dashed lines, closed circles, solid lines. Pick a point that does not lie on either line. My favorite point to pick is 0, 0 if it's available. If it's not, then I pick 1, 0 or 0, 1. Usually one of those three is available. Alright, so I pick either 0, 0, again 1, 0, 0, 1, that's really simple. Substitute that into both the original inequalities before you did anything to them. Alright? And they're either true or false. You want to graph where true, true is. Alright? So if this is my line and this point is my test point, which is true, I would shade towards the test point. If this is false, I would shade away from the test point. Alright? And if you do that for both, let's say we got this line going this way and this line going that way, the truth is up here. Alright, so it's basically you have to identify where the truth is, you shade it in. And this makes a heck of a lot more sense when we actually do the problem. So let me just, that's how we do it. Now we're going to go through the process here. So, and it's so big because I've got 2 pages here and I need to make it so we can see. So here we go. Graph the solution to this. And again, notice it says graph the solution because again, the answer is not an ordered pair. It's going to be a graph. So the graph itself, the picture is going to be the answer. All right, y is less than 1/2 x plus 2. I'm going to change that to y equals 1/2 x plus 2. That's slope-intercept form, right? Yeah. If I'm graphing the line y equals 1/2 x plus 2, the y-intercept, here's my y-axis, here's my x-axis. Y-intercept is positive 2, and the slope of 1/2 takes me up 1, right 2, up 1, right 2. Do it again and again and again until you get enough points that you feel satisfied. What type of line do I need to graph that with? A dashed line, very good. It's dashed because the original problem, this came from here, this has a less than on it, so I'm going to use a dashed line to graph that. The way you do a dashed line on your paper is you put a straight edge down, like a ruler or something flat with a hard edge on it, and just pick your pencil up occasionally. So dash, 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 that's how you do it. On my board, it draws a dashed line for me. It's kind of nice, but you guys don't have a dashed pencil, so that's how you're going to do it. So just occasionally pick your pencil up. So draw a line, pick up, and go over a little bit. That's how you do a dashed line. I say every year people put solid lines all over the place in these, so that I'm just thinking maybe people don't know how to do a dashed line. But occasionally pick your pencil up. It goes kind of like this. Dot, 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 dot. You see, like that. So occasionally pick it up and it leaves those gaps. I've seen people also accidentally put a solid line. They've actually used their eraser to erase some of the line to make it look dashed. That also is effective. It works. A little sloppier, but it does its job done. What's wrong, Maddie?
You get real close to make sure it's dashed.
I look to see if it's, if I can't see it dashed, it's solid. So yeah, I should be able to tell it's dashed. All right. The other equation, or inequality, y is greater than or equal to negative x minus 3. So y equals, I'm going to call it negative 1 over 1x minus 3. Again, if I'm slope-intercept graphing, I like my slope to be a fraction. So y-intercept is negative 3. A slope of negative 1 over 1, so take 1 down and 1 right, 1 down, 1 right, and so on. All right, so we get these points. And what type of line do I use on this one? Solid, because it has equals to. So I would graph that line like so. So there's my 2 lines. Okay. Now my job is to shade where the truth is. And my job now is to find the truth. And to find the truth, we're going to pick a test point. So what we've done by graphing these two lines, they've intersected right here. They've created four regions. This top region, left, bottom, and right. One of those regions is true for both equations. Two of those regions are true for one of the two, but not the other. And one's not true for either one. All right, what I'm looking for is one where it's true for both. So if I pick a test point, again, the one requirement of a test point is it does not lie on the lines. There's my test point, 0, 0. It's almost never on the lines. They almost always have a plus something or minus something here, so 0, 0 is usually not there. But again, if it is, 1, 0 or 0, 1 is usually available. All right, so 0, 0 is my test point. All I'm going to do is 0, 0 is I'm going to go back to both of these original problems before I did anything to them and replace x with 0 and y with 0 because that's what x and y equal. If I went with 1 comma 0, x would be 1, y would be 0. If I went with 0 comma 1, x would be 0, y would be 1. If I went with 17 comma 43, I would pick a different point. All right, don't pick 17, 43. You're making bigger numbers than you have to. 0, 0 is easy. So, if I go back up to this top equation, changing y and x both to zeros, I'm going to get 0 is less than 0 plus 2. All right? What do you think about that statement? 0 is less than 2. That's true, right? So what that tells me is the blue line, which is, this is the blue line, right? What?
Oh wait, never mind.
All right. So this is the blue line, and the 0, 0 substitution of the blue line made a true statement. My blue line's right here. The point I picked was true. That means the truth is on that side of the blue line. So for the blue line, I'd be shading this direction. I'm not going to shade yet. I just want to know. So for the blue line, everything down here is true. Everything up there is false. Okay, if I try the red line, I'm putting 0, 0 into this. I'm going to put y equals 0 is greater than or equal to 0 minus 3. What do you think about that? That looks true also. All right, so true. So the red line, this is true. This is on this side of the red line, so I'm going to shade the red line in this direction. And if I look at that and I imagine both these shadings happening, this one's going down, this one's going up, the region where they overlap is right here. Just like that. Yeah, that's the answer. The shaded region is the answer. This dashed line means that any point lying on the blue line does not count. The solid line means any point lying on the red line does count. All right? Now, the one thing people get upset about with these problems is sometimes you get a false. Let's just, for the sake of argument, let's say I picked a point that was over here. Let's say I picked this point right here. That point's obviously not in the shaded region, right? So it shouldn't be true for one of them, maybe both. All right? Obviously, if we take a look, the red line was shaded this way, so it should be true for the red, but it's going to be false for the blue, right? All right, so if I pick this point, let's just try that in the blue equation. Just see how we handle that. So, this point is 1 comma 4, right? 1 comma 4. So, if I change y to 4 is less than 1/2 of 1 plus 2, I get 4 is less than 2 1/2. Can we all see that's false?
Yeah,
Okay.
it's false.
That's my test point, which is false. So, sometimes people think, well, I got a false, I got to keep going until I find a true. No. If this is false, the test point's false, everything on that side is false, so everything on the other side is true. So if you find false, you still found true. Okay? If you find false, true's on the other side.
Yeah, there's only two sides.
If you find truth, you go to that side. So if you get true, go towards the test point. If you get false, go away from the test point. Either way, you're going to still be shading the same direction for this one. Because the blue line, red's false, true's down here. Green's true, true's down here. Either way you do it, true is down here. All right? And again, the green point's true for this. If I'd picked a point over here, I would have gotten false for the red line. That means true still over here. Shade to the truth, and where both are true is what we want to shade in.